Hi everybody, it's Mrs. Dunn. Since we have this snow day today, I was concerned we're going to run out of time, so I wanted to give you some more examples from 10.2 so that you can come to class on Wednesday totally prepared to start 10.3 and limit the number of questions I need to answer from 10.2. So what we're talking about in section 10.2 are sum and difference identities. We started talking about this last week, and I just wanted to show you a couple more examples. So in your assignment, you're going to be asked questions like this. So use identities to find the exact value of the sine of 7 pi over 12. So this angle is in radians. So you want to think about the angles that you know. Pi over 3, pi over 4, pi over 6, that's just 3 of them. Pi over 3, remember the 60-degree angle, 45-degree angle, and 30-degree angle here. Now, obviously, if you need to, you can think about pi and pi over 2 and 2 pi if those are necessary. But these are the angles that we know. And what I want to do is I want to convert them to have a denominator of 12. So pi over 3 is 4 pi over 12. Pi over 4 is 3 pi over 12. And pi over 6 is 2 pi over 12. Remember, we're making the denominator be 12, so we're multiplying both the numerator and the denominator by 4. Here we're multiplying both the numerator and the denominator by 3. In here, both the numerator and the denominator were multiplied by 2. So now what we want to do is find a combination that makes 7 pi over 12. Well, 4 pi over 12 plus 3 pi over 12 makes 7 pi over 12. So what we'll do is we're going to find the sine of 4 pi over 12 plus 3 pi over 12. Remember, because those are the angles we know. 4 pi over 12 is the same as pi over 3. And the sine of pi over 3 is the square root of 3 over 2. The cosine of 3 pi over 12, which is the same as the cosine of pi over 4, is square root of 2 over 2. The cosine of pi over 3 is 1/2, and the sine of pi over 4 is the square root of 2 over 2. And when I simplify that, I get the square root of 6 over 4 plus the square root of 2 over 4. Okay. Now I noticed in your homework you're going to have more complicated ones, like find the sine of 13 pi over 12. And so these are the angles we know, but we can't combine these to make 13 pi over 12. So then what you want to think about, now these angles, pi over 3, pi over 4, pi over 6, this is the 60-degree angle, 45-degree angle, 30-degree angle. These are all in the first quadrant. Let's think about those angles in the second quadrant that have these as reference angles. So for example, pi over 3. In the second quadrant, that would be 2 pi over 3. And that would be the same as 8 pi over 12. Pi over 4 in the second quadrant would be 3 pi over 4, which is 9 pi over 12. And pi over 6 would be 5 pi over 6, which is 10 pi over 12. Now, can we use these angles to make 13 pi over 12? Yeah. 9 pi over 12 plus 4 pi over 12 gives us 13 pi over 12. And that's why that is the answer here. Okay? All right, now let's look at another example. This is another type of question that you're going to see in the assignment. Suppose that the angles A and B are in standard position. Use the given information to find the sine of A plus B and the tangent of A plus B. And this is the information we were given. The first thing you want to do is draw two triangles, correctly identifying the quadrant of the terminal side of each angle. So you're going to have a triangle for angle A and a triangle for angle B. And correctly label the sides of the triangle with the given information. So, for example, angle A. It says angle A is between pi and pi over 2. So it's in the first quadrant. Angle B is between pi and pi over 2. So it is also in the second quadrant. Did I say second quadrant? I hope so. But those are both in the second quadrant. It's drawn correctly here. Now what you want to do is correctly label those sides of the triangle. So since we know the cosine of A is negative 4 over 5, that means the adjacent side is negative 4, the hypotenuse is 5. For sine of B, the opposite side is 5 and the hypotenuse is 12. Now use the Pythagorean theorem to find the missing sides. For angle A, it's negative 4. For angle B, it's negative 12. So first we'll find the sine of A plus B. So remember the formula, sine A cosine B plus cosine A sine B. And then I'll put in the correct information. The sine of A is 3/5. The cosine of B is negative 12/13. The cosine of A is negative 4/5. And the sine of B is 5/13. And then you just simply have to simplify that. So negative 36 over 65 plus negative 20 over 65. When I add those together, I get negative 56 over 65. Okay, now let's find tangent. So the tangent of A plus B, the formula is tan A plus tan B over 1 minus tan A tan B. So when I put the numbers in the formula, the tangent of A is negative 3/4. The tangent of B is negative 5/12. And 1 minus negative 3/4 times negative 5/12. So when I simplify that, remember up here you're going to have to find a common denominator. So the fraction negative 3/4 is negative 9/12. So I get negative 14/12 on the top. This ends up being a positive 15 over 48, but it's 1 minus that. So I get 33 over 48. When I simplify that, I get negative 56 over 33. And then also in this question, you were asked to find the quadrant of A plus B. Well, to figure out where the quadrant is, you have to look at what you just figured out. Since the sine of A plus B is negative, and the tangent of A plus B is negative, then that means since sine is negative and tangent is negative, then A plus B must be in quadrant 4. It has to be in quadrant 4 because that's where sine is negative and tangent is negative. Remember, all suckers take calculus. Cosine is positive in the 4th quadrant, which means sine and tangent are negative. Okay, I hope that helps. Feel free to go back through this screencast. You can pause it and you can email me questions, but I'll expect you to have 10.1 and 10.2 done, and you'll be all ready to go with 10.3 on Wednesday.